Hello everyone, I hope you all are doing well. This side Priya Bhatia and welcome back to my YouTube channel. So in this specific video, we will be discussing about inferential stats. I think in the previous discussions as well, I have tried to explain you the concepts of inferential statistics with respect to hypothesis testing, with respect to type 1, type 2 error. But this specific video is kind of a one shot where I'm attaching the recordings of my paid course bootcamp of stats. And in this specific video, I think if you will watch till the very end, you will not require any further video to, understand this concept. It is explained in such a detailed manner, and that's why the video is also quite long. My humble request is to watch this video till the very end and do let me know in the comment section after that as well that whether you will be able to understand the concept or not. This specific statistics plays a very significant role. Many people are already aware about descriptive stats. They know their importance in the terms of EDA, but many people are not aware about the importance of inferential stats. So, without wasting any time, let's get started and we'll try to understand this video in a lot more depth. Please make sure, as you are watching this video, try to document your learning. Another thing, please make sure you will share this video with each and everyone who wants to learn about this specific, portion in the statistical part. Specifically for data science domain, I would say it is very, very important. And with this, let's get started. Let's start our discussion with respect to the understanding of today's part, which is about the inferential stats. Uh, in the inferential stats, this hypothesis testing is something which we have to gain a great expertise over, I would say. And before deep diving into the specific concept, let's try to understand that what is this inferential stats all about? Which specific domain comes into picture? Till so far, if you remember, in our course, our focus is specifically on the descriptive part of the stats. So we have covered up a lot many different topics in case of a descriptive stats, where the major focus was on description of a data. But today we are discussing for the very first time this topic of inferential statistics. And you will observe that many people are already aware about descriptive stats somehow, because in our schools, in our colleges, uh, even when we are doing the data science job, in the projects while doing EDA, we usually get the understanding of the descriptive stats very easily, right? We know that what is mean, what is median, what is mode. We know already that what are the different kinds of distributions we have. We are already aware about the concepts of, let's say, linear algebra, and we have learned some time back, right? But I feel this is the topic which many people might not be aware of. So please take this topic very carefully, and in the chat window at any point of time, if you're getting any sort of trouble, you can just let me know. So when we're talking about inferential, it means that somehow in this specific case, we are working on getting some kind of inferences or predictions, right? Inferences. This is again an English word, inferences. What is the meaning of that? In this specific portion of our statistics, what we will do is, I hope you all know the difference between population and sample, right? Population, we have learned, it's a complete huge set of data. Uh, and sample is nothing but is a subset of that population. And in our previous discussion, I think I clearly talked about that whenever we want to work with the sample data, the main reason is that whatever conclusions or whatever inferences we are making over there, right? After doing any kind of experiment, so we do any experiment on the sample data, right? On a sample data. With that experiments, we try to get some conclusions, and these same conclusions we usually try to say that it is applicable over a complete population that we have, or a complete population data we have. Means if let's say I have a sample mean as let's assume S,
or not is, let's say it is x bar. Usually in a standard books, that's the notation. And let's say the sample standard deviation is small s, and the population mean is, let's say, mu, and population standard deviation is, let's say, sigma. So the complete idea could be that the value of x bar should be approximately equals to mu, and the value of sample mean s should be approximately equals to sigma. This is the overall idea which we want to make at the end of the day after doing any kind of experiment. And I think this I have discussed multiple times in the last classes as well. So today we will see that uh, what is hypothesis testing and what role it plays in terms of bringing up these kind of inferences, right? So when we are talking about something called as hypothesis testing, we have usually two types of hypothesis. Hypothesis means assumptions. If you will see the literal meaning of hypothesis, it means that we are talking about assumptions, right? In this hypothesis testing, we usually take one as null hypothesis, where we assume that the sample mean, which is x bar, and the population mean, let's say they both are equal to each other. And then we have something called as alternate hypothesis. Alternate hypothesis, which says that no, that is not the case. Always remember that this null hypothesis and alternate hypothesis are somehow vice versa to each other. Means whatever you will put in the null hypothesis, alternate, as the name itself suggests, it will be the vice versa of what you are mentioning in the null hypothesis. The way to represent this null hypothesis is h naught, and the way to represent the alternate hypothesis is h1. This is the, again, simple notation to represent null hypothesis and alternate hypothesis. Now, the simple idea over here is that whenever we are talking about the concept of this hypothesis, we usually try to do some experiments. When I'm saying some experiments, we are talking about the statistical tests we will perform. We usually talk about statistical tests which we usually perform in these experiments. These tests includes, which we will discuss in our next session in a lot more detail, like t test, z test, ANOVA test, chi-square test. We will discuss all of these tests in a lot more detail. Uh, so we will do these kind of experiments depending upon what kind of business use case or problem statement is provided to us, right? And after doing these experiments, we will try to make some conclusions based on the null and alternate hypothesis. At the end of the day, in those conclusions, either you will reject the null hypothesis, reject the H note, or the another conclusion you will say as you will fail to reject the null hypothesis. So either you will be having this conclusion, number one, or you will be having this conclusion, number two. So whatever work you will be doing in this inferential stats or in this hypothesis testing, your work will be completely around the focus part will be the null hypothesis, where you will try to do some kind of a testing, which we called as statistical test. And at the end of the day, your idea will be that either I will reject my null hypothesis or I will fail to reject that. Everything will make a sense that how we supposed to do this, but that is how basically the complete flow usually went in this specific case. Will that be fine for everyone? That is what we will be dealing with in our upcoming part of the uh, sessions, right? In the inferential stats. Is this okay? Till so far, any doubt? Anyone? Chale aage? There is something called as p-value, which we will work upon in this specific inferential testing. P-value is something which you can say, is providing us the probability of hypothesis testing, null hypothesis. So P is the probability of, you can say, obtaining the sample results, obtaining the, you can say, sample data results, whatever you're working with. And this is in favor of null hypothesis. Means if you have a higher value of P, means there is a higher chance that you will fail to reject the null hypothesis. If you have a smaller value of P, if you have a lower value of P, in that case you will simply say that I will reject the null hypothesis. So it means that if the P value is bigger, it is an indication that somehow our null hypothesis is correct. If it is lower, it is an indication that we should reject the null hypothesis. Is that fine? This P value is usually compared when I'm saying higher value of P or lower value of P. This is usually compared with the test which we do, like T test or Z test. For example, let's say you did any kind of a statistical test. Okay? Any test I'm talking about. And you will get some number. You will compare this number with a P value. And if let's say you are saying that your P value is bigger, your P value is bigger, in this case, I'm saying that you will simply fail to reject the null hypothesis. If it is smaller, then in that case, you will reject the null hypothesis. So your P value is usually, we got it from standard tables that we have, critical value also, same thing. So we will try to get that from a, you can say, tabular values. It's like we usually have in our lower classes Z table, Z score table. Similar to that, we have the tables for every kind of a test, and we compare those values with the calculated values, and then we try to make the inferences. If something is not clear, it's completely fine. We will do some numerical questions, and after which everything will be sorted. But I'm just giving you a brief flavor of what things we're supposed to do in this portion of our inferential stats in today's class, right? Fails to reject means we have to give reason. Yes, correct. You will have a solid reason for that, that why you fail to reject that, and that reason is nothing but P value. So if you will be having a higher P value, it is somehow a reason. It is somehow indication that the probability is very up, and that is why we are failed to reject the null hypothesis. One thing which you will always observe over here, I'm not saying that you will accept the null hypothesis. I'm not saying this term. I'm not saying this term. I'm saying this term. Always remember, the way to communicate about null hypothesis is that either we will reject it or either we will fail to reject it. We will never say that we will accept it, because there are multiple instances. It might be the case that we are doing with a sample data, right? Uh, with respect to that specific sample, it fails to reject it, but might be there exists some other possibility where it will reject the null hypothesis. So we don't know. So always remember, in a stats definition, we never ever say this kind of a term that we are accepting the null hypothesis. You will observe in a lot many YouTube videos where people are describing these concepts. They're using these kind of terms of accepting the null hypothesis, which is not correct, right? Which is not a standard way to communicate. So let's try to see again the PPT. Here, if you will be able to observe, what I'm talking about is hypothesis testing is an attempt to refute a specific claim about the population parameter based on the sample data. A few minutes back only I told you, right? So here we are just trying to apply this testing in a way that we are trying to be confident that whatever claim, whatever be the results we're getting for a sample data, is that claim is equally applicable for a population data or not. Now it is usually divided into two parts: null hypothesis, alternate hypothesis. Usually null hypothesis is the condition that is doubtful. Okay? In the problems you will observe that what is the condition which is doubtful. what is the condition that we believe in. So whatever be the condition we believe in, called as alternate hypothesis. For example, let's say I'm giving you one problem statement that heart attack has no linkage with drinking coffee. So this is something which is a doubtful statement. There might be a linkage, there might not be a linkage. So we have attached this as a null hypothesis. Alternate hypothesis will become that okay, there is a linkage with the drinking coffee. So we are saying drinking coffee increases the chances of heart attack. So these two becomes the hypothesis. One is null, one is alternate. So for every given problem statement, we our first task in the inferential stats is to identify what would be a null hypothesis for that and what would be an alternate hypothesis for that. So with solving every new question, I think you will get a better idea, but for now I hope you get a sense of this, that always null and alternate are vice versa to each other. If let's say you are saying that a patient or a drinking coffee has a no linkage with a heart attack, so alternate will become there is a linkage. If you are saying that null hypothesis is the population and the sample mean are equivalent to each other, so alternate will be saying that they are not equal to each other. So at the end of the experiment, either the null hypothesis will win or the alternate will win, and that's the whole idea of this inferential stats. So if you will be able to see here, to reject null hypothesis is to conclude that it is false. So that's what I told you. At the end of the day, when we are making a conclusion, we either reject it or we fail to reject it. So when we are saying I am rejecting the null hypothesis, the simple meaning is that whatever null hypothesis we are saying, it is completely wrong. It is completely false. When we are saying to accept null hypothesis, it does not mean that it is true. It is just that we do not have enough evidence to believe otherwise. This is important line to understand, that we never say that we are accepting the null hypothesis. Why is that so? Because we are just saying that for now I don't have enough evidence proof to reject that, but in future I might have, right? So either you will reject a hypothesis or you will fail to reject it. And when I'm saying hypothesis, I'm talking about the null hypothesis over here. Perfect. The example, both are saying same statement. I guess just the structure of sentence is different. Yes, yes, correct. See, when you are saying fail to reject null hypothesis, indirectly you are saying the same thing, that you are accepting the null hypothesis. But the way to communicate this thing is bit different. Why? Because of this specific reason, that it does not mean that it is true, because it indicates that we do not have enough evidence to believe otherwise. What is the meaning of this? For example, let's say you are doing some experiment. You always do the experiments on a sample data, one thing, right? Now, you know that we have discussed in our previous discussions, we have different kinds of sampling. And if let's say you will do wrong sampling, if you will pick up wrong sampling technique, it might be the case that for that specific scenario, you come to a conclusion. So you are doing one problem where you are saying null hypothesis is that whatever be the sample data I have taken, the mean of that, the average of that x bar is approximately equal to the population data mean. And the alternate hypothesis says that it is not equal to each other. Now you did some experiment. Experiment means that you have applied some statistical analysis, right? And with the help of that analysis, you got the values which indicates that this statement is correct, which indicates that this statement is correct. Means you are getting the sample data mean and the population mean, both are equivalent to each other. So in this case, you will not say that I have accepted this null hypothesis. You will say that with respect to this sample data, I fail to reject the null hypothesis. Why we are not saying directly that we are accepting the null hypothesis? Because it is for this sample data. But there can be multiple ways to collect data sample. There are multiple sample data which is visible over here, it might be the case there exists some other evidence, there exists some other sample data for which this specific line, this specific statement is not true. But when you are saying, and let's now you did the experiment, and let's say you are saying there is another part where you are saying that this is not equal. You are getting the values which is not equal, means the sample mean and the population mean are not equal. So in this case, definitely you got that evidence, you got that proof. So that is where you will simply reject the null hypothesis. That is the main idea. That is the main idea. It's like if you want to relate कि let's say कि हम एक कोर्ट में जा रहे हैं, we are having one case going on and judge have to give the decision. तो लेट्स से कि आप पहली बार कोर्ट में गए और आपके इस तरीके से 3 या 4 टर्न्स आने हैं. इट्स जस्ट वन सैंपल ऑफ दैट स्पेसिफिक कंप्लीट जजमेंट. तो आप गए तो आपने प्रूफ दिखाए, एंड लेट्स अज्यूम दैट आपने पहले दिन ही उनको प्रॉपरली प्रूफ नहीं दिखाए एज अ लॉयर. तो वो क्या करेंगे, वो उस केस को पहले दिन ही क्लोज कर देंगे. दे विल से दैट लॉयर डजंट हैव एनी प्रूफ, तो क्लोज हो गया, आपको रिजेक्ट कर दिया. बट लेट्स से कि आपने उस दिन बहुत सारे प्रूफ दिखाए और आपने दिखाया कि इक्वली जो सेकंड पार्टी जिससे आप कंपेयर कर रहे हो वो गलत है और मैं ठीक हूं. तो जज कभी भी पहले दिन को देख के आपको कंक्लूजन नहीं देगा कि हाँ ही इज करेक्ट वट एवर ही से, ही विल डू द अदर अटेम्प्ट. तो वो क्या बोलेगा कि अभी के लिए मैं इस केस को फेल करता हूं रिजेक्ट करने से. इट मीन्स आपकी सेकेंड आप दोबारा जाओगे, हायरिंग होगी, फिर थर्ड टाइम होगी, फिर फोर्थ टाइम होगी. मल्टीपल टाइम होने के बाद जब आपने हर बार उसको एक प्रूफ दिया कि यू आर करेक्ट, दैट इज वेयर दे विल से दैट ओके यू आर करेक्ट नाउ, और आपको आप केस जीत जाते हो, राइट. दैट इज हाउ सेम थिंग इज हैपनिंग ओवर हियर. हम एक सैंपल डेटा से जज नहीं कर सकते कि वेदर वी शुड एक्सेप्ट इट और रिजेक्ट इट. हाँ, रिजेक्ट कर सकते हैं क्योंकि आप पहले ही सैंपल में ही वो चीज प्रूफ नहीं कर रहे. बट अगर प्रूफ कर रहे हो तो इट इज नॉट गिविंग दैट आइडिया कि ये ठीक है. वट वी कैन से एंड ऑफ द डे इज कि हाँ वी विल फेल टू रिजेक्ट दैट. इज इट क्लियर नाउ? वी विल नॉट एक्सेप्ट इट. एक्सेप्ट नहीं बोलते हैं हम हमेशा यही बोलते हैं कि हम रिजेक्ट नहीं कर रहे, मतलब कि हम इसको दोबारा से प्रूफ, मतलब दोबारा से यूज कर सकते हैं इस नल हाइपोथेसिस को, इस प्रूफ को. ठीक है, दैट इज द होल आइडिया. If one hypothesis is given, then from that we should be able to find the opposite hypothesis. Yes, that's the whole point. अगर आपको null hypothesis समझ में आ गया, so you can automatically able to understand what is the alternate one. और ये जो null और alternate है वो भी आपको कोई देगा नहीं question में. You have to on your own figuring it out कि null क्या होगा और alternate क्या होगा. It's not that someone will let you know that okay this is null, this is alternate. So once we will start doing the question, you will get a better idea. Is that fine? So it is automatically, when you will do multiple number of times, then it is automatically proven ना. But वो एक exact ratio हमें पता नहीं है. तो यहाँ पर इस specific questions में what we supposed to do is we focused on the null hypothesis and our focus is on rejecting that. Depending upon the p value, depending upon the critical value, accordingly we will focus more on rejecting part. ऐसा हम सोच के चलेंगे कि हमें कभी भी ऐसा हाइपोथेसिस नहीं लेना जो कि गलत हो. दैट्स द होल आइडिया. Our perspective is completely different in these kind of questions. That's the whole idea. Okay, so let's move ahead now. Type 1 and type 2 error is fine. I don't want to discuss this for now. इससे पहले let's discuss one problem, and then maybe I will come up with this question again, so that whatever points I have conveyed over here will start making sense to you. ठीक है, तो इसके लिए I will try to pick up one question, one numerical problem. And this is the numerical problem that I have with me, so that whatever flow I have explained just now will be pretty much clear to everyone. Just listen this very carefully and try to get the understanding. Whatever things we have covered up, if you get this numerical problem very much aptly, you will get a appropriate understanding for the same. Okay? What they're saying, the average height of adults in a certain country is known to be 168 centimeter. Let me know whether this is a talk about a population mean or a sample mean. Let me read it further. A scientist believes that average height of adult in a certain city in that country is different. The scientist measures the height of 40 randomly selected adult residents, finds an average of 171 with a standard deviation of 7. Test the scientist hypothesis at 0.10 significance level. So tell me that this 168 is a population mean or a sample mean. This is nothing but I would say is a population mean. Right? This is nothing but is a population mean. Can we say everyone from this problem statement? Is that completely understandable? Right? After that, if I will ask you how many number of samples we have, so we have 40 number of samples, right? Number of samples are 40. The sample mean, which is x bar, is, can I say, 171? And the sample standard deviation, which is S, can I say it is 7? Right? All of these are the given parameters to me. Now, in this problem statement, if I'll ask you, what is the null hypothesis and what is the alternate hypothesis, what will be your answer? See this very carefully. We are saying the average height of adults in a certain country is known to be 168 centimeter. This is the thing which we are doubtful about, right? So we are assuming that null hypothesis is that the average height is equal to 168 centimeter. This is what null hypothesis says. So if null hypothesis is this, what is the alternate one? What is the alternate one? If I'm saying null hypothesis is that the average height, so we are saying that, okay, it's a correct statement that the average height is equal to 168 centimeter. So what will be the alternate one? Alternate one will say that average height is not equal to 168 centimeter. So this is the very first step in any problem to find it out what is null hypothesis and what is alternate hypothesis. Now, at the end of the day, I will solve this problem to figure it out that either this null hypothesis I will reject or I will fail to reject. That is the whole point. Is that part is clear what we are doing now? 171 is for the sample part. Again, this is not for a population one. What the researcher is saying? Researcher is simply saying one statement. Scientists believe that average height in a certain city in that country is different. They are not saying what is exactly that height is. They are saying it is different from 168. So different means that mu is not equal to 168. We don't know what is that. It might be anything. They are talking 171 for the 40 randomly selected points. But that is not for a population one they are saying. They are saying that for the population it is different from 168. So alternate will be it is different. It is different. And null will be that it is exactly equal to 168. Will that be fine? Is that okay for everyone? Chale aage? Shall we proceed ahead? Yes? Now what we supposed to do? Usually in these kind of problems, when we will be having this specific values given to us, we will be focusing on the kind of distribution it holds. If let's say this distribution of height of adults Usually, if you will be taking this specific kind of problems, the height, the age, and you will try to see the format of these distributions, this is a normal distribution. And in these kind of distributions, we try to apply something called as either z test or t test. Now, what kind of test is being applied over here? It depends on various factors. The very first thing we have to see in a given problem, that is the value of standard deviation, population standard deviation. Is that available with us or not? So in this given problem, do we have a population standard deviation? No, right? So we have to check that is the population standard deviation is given to us or not? Yes or no? If let's say it is given to us, we will check the number of samples. Is the number of samples is more than 30 or not? If let's say number of samples are more than 30, we usually go with the z test. Otherwise, we will go with the t test. Okay? And if let's say the population standard deviation is not given, then for sure we have to go with the t test only. So in this way, we are either focusing on z test or t test depending upon whether the population standard deviation is available or not. If it is not available, we will directly apply t test. If it is available, we will check the sample size. If the sample size is small, less than 30, in that case, we will again apply t test. Otherwise, we will apply z test. When I'm saying we will apply t test or z test, there is a formula for that. For a t test, the formula is x bar minus mu divided by s upon square root of n. And for z test, the formula is sigma x bar minus mu upon sigma upon square root of n. This is the formula of t test and z test. Now, in this specific question, can you help me to understand what kind of test we should apply? So now we are focusing on doing the experiment. When I'm saying experiment, we are focusing on applying the statistical test. So in this specific question, what kind of statistical test we supposed to apply? Tell me, and why? Why we are taking 30, I'll explain you. Please give me a moment. For now, just give me an answer whether we should go with a t test or a z test. Here in this specific question, whether we should go with a z test or a t test. In this question, the value of n doesn't matter, right? Because the value of sigma is not given. So in this case, only s is given to us, sigma is not given to us. So we will go with the t test. So in this case, what we will do is we will apply the value of t as x bar minus mu upon s upon square root of n. So the value of x bar in our case is 171 minus 168 divided by the value of s is 7 upon square root of 40. Just solve this particular answer and you will get some result over here. Now the question why it is taking n as more than 30, this 30, how it is coming up? It is a hyperparameter. What is the meaning of hyperparameter? Means the researchers have done multiple experiments. They want that the number of sample size should be enough so that we can make an appropriate judgment. It is similar to the central limit theorem. If you will be able to observe in the central limit theorem also, I told the similar statement that when you are taking a sample mean, those sample means and doing the average of that should be more than 30. So this 30 is something which makes a big number with respect to giving an inference for a complete population data. How it is coming up at it as 30 only, why not 40, 50, 60, 70 or so on? It's being experimentally proven by doing multiple experiments, right? So that is where this number is coming up. But by saying that, if let's say you are dealing with a very huge amount of data and still you are taking let's say 30 value, it doesn't make much sense. So always be that much sensible enough that we will take at least 5 to 10% of our population sample data, so that our sample inferences will make a significant impact over the population data that we have. But in this specific case, that's the main reason behind this. Is it clear now? So, what is the answer we are getting over here? I have solved this question, and the answer for this problem is, I feel, 2.71. You can check it at your end, it will be 2.71. Okay. Why sigma value is not given? We will always go for directly t test. Yes, when the sigma value is not given, you will always go with the t test directly. Okay? To evaluate the z value, you need sigma in the formula. If it is not given, you will always go with the t test. Is that fine? So far, so good. In this case, first of all, what we have done, we have tried to evaluate what are the parameters available in this question. Mu, n, x bar, and s is given. The very first thing, the very first task number 1, is to evaluate what is null hypothesis and what is alternate hypothesis. So, given this problem statement, what they have said, that the average height of adults in a certain country is known to be 168. Scientist believes that this is something which is different. So our null hypothesis will be that for that specific country, the average height is equal to 168. Alternate will be the vice versa of that, means the average height should not be equal to 168. The task number 2 is to evaluate which kind of statistical test we should apply. Now, there is a flow for the same. When the value of sigma is not available, directly go with the t-test. If the value of sigma is available, check the size of sample. If it is more than 30, go with z-test, otherwise go with the t-test. The formula to evaluate the z and t value is mentioned over here. So in our problem, the value of sigma is not available. So we have went towards the t value, which is x bar minus mu upon s upon square root of n. We have used this formula and got the value of t as 2.71. Is the two tasks that we have done in this numerical problem is clear now, everyone? Mayank, is this clear to you? Shall we proceed ahead?
What is the significance of using t-test and z-test?
Are you saying something? Mayank.
Hello.
Yes, please go ahead. Is it fine?
I guess my net was disconnected, but what is the I understood the formula that for t-test and z-test, but
Mhm.
what is it is signifying basically? I am not able to understand
So
that t.
basically, this is signifying the distribution of your data. Distribution of the data. So if your data distribution is a normal or symmetric distribution, in this case, we will go with this kind of, this is a statistical test. This is a statistical test. So what we are considering over here, that the height of people follows a normal distribution. And in that specific scenario, we will either apply a z-test or we will apply a t-test. Why we are doing so? Why we are evaluating this? Because of getting that conclusion that either we should, so basically what we want at the end of the day, we want the conclusion that shall we reject the null hypothesis, or we fail to reject the null hypothesis. So, how we come towards this specific conclusion? These are the steps I'm trying to convey over here. That The very first thing, you have to infer what is null and alternate. The second part is you need to evaluate the statistical test, which is an experiment which you are doing over the given data points that you have, with which you will be able to get one value, which is 2.71 over here. And now this value in the task number 3, you will compare this value of t with a critical value. And this critical value you got from a table of t. So you will get this value from a t table with the help of this factor of significance level, which is represented by alpha, which is equals to 0.10. I will talk about this specific term in a lot more detail in the upcoming part. But for now, you can assume that from table we got some value, which is exactly, let me write it down. What is the value we are getting? This is 1.68. Okay? How we got this value from table, I will let you know. But for now, just uh, see that there is a hypothetical value which we are getting from a given desirable table from a Google, and we got this answer as 1.68. And there is a one value which we have just now evaluated, which is 2.71. Now, in the task number 3, we will compare these two values. If this critical value is smaller than the t value, so this critical value is a proof of fail to reject the null hypothesis, or in other words, accepting the null hypothesis. Because the t value is bigger and critical value is smaller, because the critical value is smaller than the t value, in this case, you will make a conclusion of rejecting the null hypothesis. So this is the flow of doing any kind of a inferential stats. So in this conclusion, we will say that we will fail to reject the null hypothesis. Sorry, we will reject the null hypothesis. This is the conclusion. So always remember, whatever be the statistical test you are getting, you will compare that test value with a critical value. If that critical value is bigger than the statistical test, then you will make a conclusion that I will fail to reject the null hypothesis. If the statistical test value which you are getting, for example, in our case, which is t test value, is more than the critical value, in this specific use case, our conclusion will be that we will reject the null hypothesis. This critical value is a support of the null hypothesis, right? Which is a tabular structure which we got from the table. Okay? So we will try to compare this specific value which we are evaluating with the critical value. If the critical value is bigger number than the statistical test, then we will not reject the null hypothesis. We will fail to reject it. Otherwise, we will reject it. That is something which is the flow via which we will try to make conclusion in any kind of a problem. Is it clear now?
Yes, ma'am,
Ask
it
me
is
any
clear.
questions if you have.
I have a question
Others also.
for that
Yeah, please.
Z test and T test. So what is,
Hmm.
for example, we have to use T test when the sample size is less than 30. So what changed in the formula because of that?
This is
Rather,
the
I
only
can say that
change.
how, okay, how the formula is derived.
Yes, there is a complete appropriate derivation for the same. Just like the way we have the derivation for variance, standard deviation, and all those stuffs. That derivation I am not covering up in this specific course. This specific thing, if you want to check again, you can refer the YT videos. But majorly, if you will try to observe what they're trying to give us as an output is the difference between the population value and the sample mean value. We are doing a test to examine that whether our parameter of population and sample are approximately similar or not, right? That's the whole idea of doing inferential test. So intuitively, if I have to explain you this specific stuff, so just try to see this formula very carefully. What is happening? We are trying to take a difference between a population value and a sample value, average of sample mean and a population mean. And we are dividing that with a value of sigma or s upon square root of n. So what we are doing over here is, this is a term, whether it's a z or t, which is a factor which is defining that how much is the variation between the sample value and the population value. That is something which we are deriving over via doing z or t. Now, with the help of this factor, we are comparing that with a critical value factor. And if that critical value factor, which is derived by a given table, which is a standard value, if it is bigger, it indicates that whatever be the value you are getting for a sample data, na, it is not correct. It is not giving a confidence of a complete population. Means you are rejecting the null hypothesis. You usually fail to reject the null hypothesis. And if it is vice versa, means if your value of deriving via ZOT, you are getting it very great, which is more than the critical value itself. In that case, you are rejecting the null hypothesis. That's the main idea. The complete derivation over there, if you will deep dive into that derivation also, it will take again too much complexity of the session. I don't want to go inside that. If you want to explore that what is the exact derivation to derive all of these formulas, maybe I will again share with you the videos also. You can refer any of the YT videos where you will get the idea that how these formulas are being derived. But the intuition is what I have shared over here.
Yes, ma'am.
Similarly, for other statistical tests, for example, in future sessions or in future classes, we will discuss about chi-square, we will discuss about ANOVA. So in the sessions here, I will discuss the formula of that how basically we will be able to formulate chi-square and ANOVA. But if you want to see the derivation of how the chi-square formula or ANOVA test formula or z-test formula or t-test formula comes up, there is a proper proof. Research papers, derivations are already available in maths. You can go and explore at your end. I will, if you want, I will show you the resources for the same. But in the sessions and the live classes, we will not go in that much detail. Can there be a scenario that statistical test is equal to critical test, or that will never happen? No, that won't happen. So it will be either bigger than that or it will be smaller than that, the critical values, right? Will that be fine? I'm just taking up one question over here. And you need to try to apply whatever knowledge you have gained, and then maybe we will move ahead. So this is the problem statement. See this very carefully. One more thing. If let's say there exists some rare scenarios where वैसे तो we usually don't get, but still if you are getting that kind of a scenario where approximately, not exactly but approximately, the value of evaluation is almost equal, so in that case you will, for this kind of a scenario where the conclusion you will make is that it will be failing to reject the null hypothesis. See, if I'll try to showcase you this as a part of understanding. So I talked about that in we will apply z test or t test when we will be having a normal or symmetric distribution. How this distribution looks like, I hope you all know that we have a bell-shaped curve for these kind of distributions. This is a kind of a curve that we have, right? When we're talking about normal distribution. So in these kind of distributions, this is what we called as the portion where what we want is our maximum data will lie. So let me try to plot it in a more better way if I can. So this is a normal distribution we have, and there are extreme ends. So if you remember that these are the extreme values, right? These are the extreme values in this normal distribution. So what we are saying when we are saying the value of alpha is 0.10, this alpha is a risk factor. Risk factor. It indicates that how much risk or how much is the tendency of error you want to entertain in your data, in your experiment, in your proof. So what we are saying is that when the value of alpha is 10%, it means that 5%, or you can say 0.05 chances over here, 0.05 chances over here. It means that if my statistical test values lie in this extreme regions, then I will reject the null hypothesis. If the values in the experiments lie in this specific regions, I will simply fail to reject it. So always remember, we are focusing on these extreme ends. These extreme ends. The risk factor, this is the value of alpha. So significance value, like for every kind of work which you are doing in the industry, there will be a risk factor associated with it, right? That how much error you can entertain in your work. So let's assume that they are saying that we can entertain 10% of error. It means that 5% in the left extreme, 5% in the right extreme. So it means if n data lies in these extreme ends, I will not accept the null hypothesis. In other words, I will reject that. If the data points lie maximum over this specific region of acceptance, I will definitely fail to reject it. That's the whole idea, right? So whenever you are saying that my test is approximately equal to critical value, it means you are saying that maybe I am having a data point available over here, exactly at same point. So what I will do? So in this specific case, if this is happening, you will fail to reject the null hypothesis only. You will not reject the null hypothesis in that case. So that's the whole idea. But anyhow, if it is bigger than the critical value, in that case, you will definitely reject it. What this situation indicates that your statistical test values lies in this extreme ends. And if it lies in extreme ends, you will reject the null hypothesis. You will not favor it, you will not accept it, you will simply reject it. That's the whole idea. Why statistical values cannot be equal to, so I told you, right, it can be in a very rare situations, because those critical values are the standard values which we have. So if let's say that situation exists where they both are equal, maybe in this specific range, so you will not reject it, you will fail to reject the null hypothesis in that situation. Is that fine? Okay. So any kind of test, if it is lying among this specific area, this is the area of acceptance. Extreme ends are the areas of rejection. So that is the visual appearance of what I'm trying to convey over here. Is that fine, everyone? Okay. Shall we try discussing this once more with one example, and then maybe we will move ahead? So here you can see a gym trainer claimed that all new boys in the gym are above the average weight. So there is a gym trainer who claims that uh, all the new boys in the gym are above the average weight. A random sample of 30 boys picked up has a mean score of X bar 112.5 kg. The population mean weight mu is 100 kg, and the standard deviation is 15. So I think this is what they have given as sigma. Is there sufficient evidence to support the claim of the gym trainer, consider the value of alpha, which is the risk factor, is 0.05. This alpha is basically helps you to find the critical value from the table, which I will showcase you later on. But anyhow, given these values, can you tell me how will you solve this problem? What is the first task we're supposed to do? What is the first task we're supposed to do? What is the null hypothesis? Task number one is to check that what is the null hypothesis and what is the alternate hypothesis. So, what is the null hypothesis? A gym trainer claimed that all new boys in the gym are above the average weight. Are above the average weight. And what is the average weight? It is 100 kg. So, is there sufficient evidence to support the claim of the gym trainer? So, gym trainer says that the value of mu is more than 100 kg. Null hypothesis says that let's say it is not more than, it is less than or equal to 100 kg. Right? This is the null and this is the alternate. So what we have to prove is that whether that gym trainer is correct or not. So gym trainer says that the average height is more than 100 kg. More than the, the average height is more than what they have said is the new boys in the gym are above the average weight, average weight. So average weight is 100. So it means mu is more than 100 kg. This is told by gym trainer. Null hypothesis will be obviously the weight will be less than or equal to 100 kg. Now we need to provide some evidence, some proof to either reject this null hypothesis or to fail to reject this null hypothesis. Will that be fine? Again, listen this problem statement. What we are saying, gym trainer claimed that all new boys in the gym are above average weight. So what is his claim? His claim is that all new boys in the gym are above the average weight. This is what he is claiming, right? It means that he is saying that all the weights, like the value of mu is more than 100 kg. Am I saying it correctly? This is what he wants to convey. He's claiming that. He's not sure. He's claiming that this is what is the case. So if you will be able to observe, this is what is told by trainer, gym trainer, that the value of mu is more than 100 kg. What is the vice versa thing for that? It will be either less than or equal to 100 kg. In maximum instances, you always remember the null hypothesis is the one where you will be having an equivalent symbol. That is the maximum instances you will get that. Equal to. So either the weight will be equal to 100 kg or less than that. This is what the initial judgment. Now gym trainer come and he claimed this thing. So we have a null hypothesis, we have an alternate hypothesis. And now we start working with it. Right? Chale aage. Now the task number 2 is to detect that which kind of hypothesis we should apply. So again, it's a weight problem having normal distribution. So which kind of testing we should apply over here? Is it t-test or a z-test? It will be a z-test, right? Because sigma is available. Sigma is available. Now again, this the value of n is exactly 30. So if it is, again, let me write it equal to. If it is more than equal to 30, yes, in that case, go with the z-test. So it is equal to 30, that's fine. So we can go with the z-test. Now the value of z is x bar minus mu divided by sigma upon square root of n. X bar, we know the value is 112.5 minus average is 100. Sigma is 15 upon square root of 30. We will try to evaluate this value of z. So what is the value we are getting? Can anyone confirm to me? This value seems to be 4.56. Now, what you will do? Task number 3 is to compare this value with the critical value. For now, let's assume I am saying that number from table, the critical value is coming out to be 1.645. Okay? How we are getting that? Again, I will showcase you in the upcoming part. But for now, we need to compare now this z and this critical value which we are getting from the table, from the z table. Now, tell me what is the final conclusion you will make. Either you will reject the null hypothesis or you fail to reject it. Tell me, is it correct? So far, so good. Tell me what is the conclusion I should make. Yes. So in this case, again, you can easily observe critical value is not bigger, right, than the statistical value which we are getting. So we will reject the null hypothesis. What is the meaning of rejecting the null hypothesis? It means that we are saying that the whatever the gym trainer is saying, that the average weight is not less than equal to 100 kg, right? So it is more than 100 kg. He is correct, right? That's the main inference. Is that fine? What I am trying to convey over here, over there? देखो, alternate is the condition that we believe in. So when a trainer is claiming that okay, this is the height which is more than 100 kg, this is his belief, this is his claim. So that is an alternate one. The condition you are doubtful is that the value is either less than or equal to. That is where we have picked up in a null one. Another tip which I have just now talked about few minutes back, the equality usually come in null hypothesis. And the question which they are saying that they are claiming, that will be coming under the alternate one. That is the way to examine which one is null, which one is alternate. Is that fine? Is that okay? Is that flow is clear? What is we are doing in this inferential test? These examples are just to make you understand. Today, my objective is not to make the things more complex. I just want to showcase you the objective of this inferential stats. I just want to give you a intro or a brief idea about why this inferential stats is important, because we always see the application of descriptive stats in lot many scenarios in our day-to-day work, but we need to equally appreciate the inferential stats also because of what we are doing over here. But many people are not aware of these facts. That's why I am discussing it with the examples. That's the whole thing. I'm not expecting that 100% things will be clear in this session. That's why I have split this module into 2 sessions. One session we will take another part where I will talk about more details for whatever work we are doing today. It's just take it easy, take it just as an introductory part, and after the session will get over, try to deep dive more into it, see the applications of inferential stats in real time scenarios, try to read articles if you can, try to refer GPT platform if you can, try to see multiple examples or numerical problems of the same to get the better idea of it. That's the whole idea. Okay? We have to do all in Python code, isn't it? We will do Python code for the same in the upcoming class. Please don't worry of all of these things. Whatever things as per the code requirement is required in the companies, or you should know that I will definitely complete those things in the course itself, in the live classes itself. Remaining things, definitely, I also have a limitation of the time. If you want to explore, please do it at your end. It's a very short crisp course I want to make, so that whatever things are mandatory to know for anyone who wants to enter into data science domain, they should know that. Apart from this, as I told you, stats is a very big domain. It cannot be covered within 10 to 11 live sessions. It's quite impossible. Just those topics, those examples I have tried to explain over here, which I feel is important if anyone wants to enter into data analytics, data science domain. Everything I'm not covering up in these classes. That's the whole point. Okay? Okay, perfect. Let me read the questions. In terms of mathematics, I am able to understand, but in terms of inferences, I am little ambiguous. When we will discuss about the case studies, that will also make you a sense that what we are doing over here in terms of projects in the inferential stats. So we don't know if the belief is true or not, whether it is fact based or logical or not, and we use hypothesis to conclude the same. That's a very apt statement, Mayank. That's the whole point to convey over here, right? Uh, Perfect. Now let's move further, and I want to discuss one more topic, which is very important as per the interviews as well. And then I will discuss, if time permits to me, one case study of healthcare where I will try to showcase you that whatever things we are learning over here, how we can apply the similar knowledge in the projects, or how the companies are applying this inferential stats knowledge, which hypothesis testing we're talking about today, in their projects, right? Whole thing we will try to cover up so that complete session will make a sense to everyone, right? What we have done today. So we have talked about null hypothesis. We have talked about today alternate hypothesis. Now, I will try to create one matrix over here and try to understand this matrix very, very clearly. In this matrix, we have two components. The very first component, so I'm talking about this specific matrix, where this is the actual data or actual result. And this is an experimental result. The experimental result meaning the result which you are getting after doing any kind of experiment via z test, t test, chi-square test, ANOVA test. Now I think you know what is the meaning of experimental, right? Actually, let's assume that your there are two components. Either your null hypothesis is actually true, or your null hypothesis that you are making is actually false, right? Experimentally, also you can make two conclusions. What are those two conclusions which we are making? Anyone can let me know? We have done two examples for the same. So, actually, whatever be the null hypothesis you are taking, it will be either true or false. There can be two possibilities. I'm saying experimentally, when you get the results, what are the possibilities we can get over here in the experimental results? Can I say either we will reject the null hypothesis, that's the first result we can get, or the other result could be that we will fail to reject the null hypothesis. Do you guys agree with me on this four values which I have written over here in this vertex, in this specific matrix? Is that fine? Now, let's assume a situation, and please, this is a very important topic, widely asked in interviews. So be very attentive what I'm trying to convey. At the same time, it feels confusing for many people. So that's why I'm paying more attention towards it. That's the main reason I have given you examples prior before coming to this topic, right? Let's assume that actually your null hypothesis is correct. Actually, your null hypothesis is correct. Means whatever be the assumption you have made of average weight equal to 168 centimeter, that's a correct statement. That's a correct hypothesis. And you done the experiment, and your experiment failed to reject the null hypothesis. Is this a correct experiment or a error? Is that a correct experiment or a error? Means what I will fill over here. Is this correct experiment? Your experimental results are correct, or is that an error? I am asking from you. Your null hypothesis is true, and your experimental conclusion is that I will fail to reject the null hypothesis. This is correct. This is not an error. Again, listen. Null hypothesis is true, meaning, for example, your hypothesis is, few minutes back we have done one example, mu is equals to 168 centimeter. Average height is 168. You have done experiment and you are not rejecting the null hypothesis. You are somehow saying that null hypothesis is correct. It is accepting it. So it means that you are saying correct. Your experiment is correct, it means. Will you agree with me? Will you agree with me? What if your null hypothesis is correct, but your experiment reject it? Is this correct or error? Is this correct or error? This is error. Will you guys agree with me? This is error. Will you guys agree with me? Yes. Same thing let's apply over here. Now let's assume that the null hypothesis is actually wrong. Means when you are saying mu is equal to 168 centimeter, average height is 168, this is wrong assumption. And your model or your experiment reject that hypothesis. Is this correct case or a error? Is this correct case or error? This is correct. Agree? Assume your actual value null hypothesis is wrong, mu is not equal to 168, and your model fails to reject the null hypothesis. Your experiment conclusion is that I fail to reject it. Is this correct or error? This is error. Is this four boxes which I have filled now? Every box, why I have mentioned correct and why I have mentioned error, relate with the previous examples. The only reason today I have given you those examples is not to talk about numerical problems that we will do in upcoming class with the implementation of a code. Today's objective is to give you this metrics understanding, because of which I have taken those two examples to relate it very clearly and to understand error and correction point. Because these things you cannot cram it, you have to understand it. Why this block contains an error and why this block contains an error. Yes, this is a kind of a confusion matrix you can relate. So, machine learning concepts confusion matrix is directly correlated with this concepts only. But this is a perspective of stats, that is a perspective of ML. That's the difference. That ML confusion matrix comes from this concept, I would say. The parent is this, that is the child of that. So this is the main concept. This is the maths behind confusion matrix, from where that concepts of precision, recall, accuracy comes up. Today we are discussing about the internals of that. No, we don't have alternate one. See, we always focus in our experiment null hypothesis. And you only understand, right? If null hypothesis I'm saying is true, automatically alternate is false. So why there is a need to curate a separate metrics for both of them? At the end of the day, they both are vice versa of each other, right? So if we are making inferences for null, automatically we have an inference for alternate one, isn't it? It's just that in mathematics, in a standard books, you will never ever find the word of alternate. We are not doing experiment for alternate, we are doing experiment for null. That's a convention, but it's not that you have to follow it. But still, if you will refer any kind of articles, any kind of books, any kind of problems, you will always follow this convention of null hypothesis. So now, in these four quadrants, you will see there is one called as type 1 error, another one is called as type 2 error. When your null hypothesis is true, so we got two errors, right? This is what we called as, other name is type 1 error. And this is another name is type 2 error. So what interviewers ask from you is that, tell me the difference between type 1 and type 2 error. So type 1 error is when your actual null hypothesis is true, but your experiment rejects that. Type 2 error is vice versa. So if you will be able to understand any one error, maybe type 1 you can remember or you can understand, type 2 is the vice versa. Vice versa meaning actually your null hypothesis is false, but your model fails to reject it. That's the whole point. That's the whole idea. Is the difference between type 1 versus type 2 error is clear to everyone? Let's try to take this now with the help of an example, and after that, we will try to wrap up the today's class. Inspector has to choose between certifying a building as safe or building as not safe. This is the problem statement. Let me copy this problem on the sheet. So there is an inspector who came to choose that whether the building is safe or not. So if you will go in Bangalore, Gurgaon, Noida side, there are multiple flats projects going on, right? So there is an inspection which usually happens that the builder who is building those bigger buildings or flats, whether they are safe or not. Now the null hypothesis is something which we will say that building is not safe. This is what we are doubtful कि building safe नहीं है. Alternate will be the vice versa, that building is safe. Now if I'll ask you, in this case, what is the type 1 error? If I'll say that type 1 error, how will you convey the type 1 error to me? What is a type 1 error in this case? Type 1 error is when the null hypothesis is actually true. What is the meaning of that? Actually building is not safe. Actually building is not safe. But experimental results, what they are saying, reject null hypothesis, means experimental results conveys building is safe. Building is safe. Can I say, everyone, this is the type 1 error? Actually building is not safe. Actually null hypothesis is true, but experimental results reject the null hypothesis, means they are somehow accepting the alternate one. They are saying building is safe. Is this an error? Is this an issue? Yes or no? Is this correct statement what I am writing over here? See this? Type 1 error. I think that is what I have mentioned over here. Type 1 error is committed if we reject building is not safe when it is not safe. I am writing this. It might be confusing, so please see this logically, otherwise you will get confused. Type 1 error is committed if we reject, this is the null hypothesis, right? Building is not safe. So we are rejecting the null hypothesis when actually it is not safe. Or what I have mentioned is same thing. Give me confirmation, is this okay? Before we will move to type 2 error. Yes, this is a major issue. Major issue. That's true. You can consider this type 1 error as a major issue in this case because building is actually not safe, and experimental results saying building is safe, people will come, stay there, and let's suppose in future maybe rain came in Bangalore, it's too much, right, on a daily basis. What will happen? Maybe buildings collapse with each other. There is a huge issue in terms of the people saviors, people health, and so many things are the external factors over there, right? Any external factor will come, tsunami, earthquake, anything like that. Definitely people will die because they are living in a unsafe building. What is type 2 error? This is important. In this instance, what is type 2 error? Tell me. Now, see this matrix. Type 2 error is when H0 is false, meaning H0 is false, meaning building is safe. Actually, building is safe. That is where we can say that H0 is false because H0 is saying building is not safe. It means actually building is safe, But but experimental results experimental results fails to reject null hypothesis. Means experimental results says building is building is not safe because they fail to reject null hypothesis. It means they are saying that building is not safe. Is this an error? Actually, building is safe. Inspection happened, experimental results come out, building is not safe. Is this an error? Yes, this is also an error. We cannot say it's not an error, but definitely this is not that much critical error as comparable to type 1 error. But this is also an error, which we called as type 2 error. So if I'll just again copy this statement in a more formal manner, so this is the complete idea. Type 2 error is committed if we fail to reject building is not safe. When it is safe, so you fail to reject the null hypothesis when it is actually safe. Now it is clear what is the difference between type 1 versus type 2 error. Very important topic. Very important topic in inferential stats for interview perspectives also and for doing multiple projects also. You should know your main task is to avoid these errors, type 1 and type 2. Is this fine for everyone? Any doubts, anyone, in these two parts, in these two components? Now, is this session making sense to you guys? Maybe initially, when I started this discussion of inferential, might be you felt what she's talking about is completely jargon for us. But now, because we are moving towards the end of the session and you have listened me from past 1.5 hours, is it making sense now what I'm trying to convey over here? Yes, everyone? Can I get some confirmation from others as well? Correct? Perfect. So, this is the whole point of today's part. Now, I will try to wrap up this class before jumping towards a case study so that everything, whatever we have covered up, is properly clear to everyone. So, let's do one case study and then we will wrap up the class. Because few minutes back, I think Prabhutva mentioned that is it this is fine that you are talking about in a mathematical terms all these stuffs making sense to us, but how can we apply this knowledge in the real time use cases, real time projects, or whatever we are doing in our work of data science pipeline or data analytics pipeline, right? Because when we're talking about descriptive stats, we know like in EDA what are the steps where it is useful, right? And when you work with ML projects you will get to know more about this, but we never see these kind of things, right? So where it is helpful, how we can apply this, let's do one case study. This case study is about, let's say, healthcare domain. And let's assume you are a part of that team, of healthcare domain team, where you are working with one problem statement of detecting cancer patients. Okay, so you have a data set available with you. It's a numeric data which has details of patients' past history, their BP level, their diabetic level, all the diseases whatever they have in the past, and the stage of let's say we are trying to diagnose that whether the patient will be suffering from a cancer or not, whether they have a cancerous cells in their body or not. That's the main problem statement. Now, if I will try to work upon this kind of a problem and you are working in this specific domain, what will be your null hypothesis and what will be your you know I would say alternate hypothesis. So usually what happens when we start our project, we will make some assumptions with respect to the given data. Obviously, let's say in the healthcare domain, we will be having all over the all over India, let's say, so many data points available and population size is very huge. And let's say by detecting the cancer patients, we are doing just a survey that in which specific area, in which specific region, let's say we are having a north and a south. We want to do a survey that in which specific region of north and south maximum cancer patients are available. We don't know. We are doing a survey. We are doing a experiment for that. So when we're talking about healthcare domain, definitely in north also there are multiple locations available. Inside that we have multiple cities, we have multiple villages. Getting each and every sample data is not possible, right? It doesn't make sense. So the population is very huge. Population is very huge. So what we will do? We will try to take a sample data of the places available in north side and south side. And whatever be the inferences I will make, I will say that same inferences will be available, will be applicable for the complete population data that we have. That's the sole idea. That's the whole idea. So, what will be the null hypothesis and what will be the alternate hypothesis in this problem, in this use case? Tell me. As per your side, what will be the null hypothesis? What will be the alternate hypothesis in this problem? Okay. So, that's true. Null hypothesis is that patient has cancer and alternate will be that patient does not have cancer. This is this specific problem statement or use case is composed of two components because I have broadened it up into north and south. But for now, let's make it very simple problem that we are working with a simple problem of detecting the cancer patients. In this case, what you are saying is quite correct. Let's say for now, I am just working with one region. I'm just taking a data of Delhi people who are staying in Delhi. I'm just seeing that maybe Delhi people, and let's say I'm working with the AIMS patients data. Okay? Hospital is also I have specified. So null is patient is suffering from cancer. Alternate is patient doesn't have a cancer problem. That is something with which we will start our assumption. Now, what will happen? This is task number one. Task number two will be that you will apply the statistical test or you will apply any other ML specific use case, maybe any algorithms you will apply, right? Whatever you are doing in the task number two, just to get that result. If you're applying statistical test, you will compare that with a critical value. If you're applying any algorithm, you will compare it with the evaluation metric. And then at the end of the day, in the task number three, you will compare that values which you are getting with the, let's say, critical value which you are having if you're applying a statistical test over there. And either you will reject the null hypothesis, meaning you will say that, okay, that patient uh, does not have cancer, right? Either you will reject that or you will fail to reject it. Fail to reject it. When you are saying fail to reject it, means it means that that patient is having a cancer. So in this way, in all the problems, we apply these hypotheses, which is null and alternate, and we will do some testing, we will apply some algorithms, we will do the inferences, and the task three, as per the above task two inferences which we are getting, we will make the conclusions. of the test that we are doing. That is how in projects things will be done. Will north south affect the hypothesis? Yes. If let's say now you are working with that same problem which I was talking about, north and south, we're not working with any specific center. So, in that case, for detecting the cancer part, the same analogy you will apply. But on top of that, again, for the main question, whether north or south, in which specific region the patients have highest cancer rates, right? So, in that case, again, you will apply the null hypothesis that let's assume north people have a highest rate of cancer. Alternate will be let's assume that south region have a highest rate of cancer, and then you will take their data set, do the test, and then finally you will make a prediction. Either you will reject the null hypothesis. If you're rejecting it, means somehow you are claiming that south will have highest rate. If you are failed to reject it, it means you are claiming that north will have a highest rate. That is how the complete analogy will get changed in that scenario. So always remember, whenever we are doing any kind of a task, the starting point will be that choosing the null and alternate and accordingly doing all the task. Will that be fine for everyone? Is that okay? Getting the understanding that how these things are applicable over the projects? What about others? Fine. This topic is not finished yet. Today, whatever things we have explored, please try to deep dive into it. Whatever time you have, do more research on your side. I will take one more session for the same, and then we will finish this topic where we will do the implementation and we'll do the discussion of other two tests, which is ANOVA and chi-square. And afterwards, we will wrap up this topic in the next class. Perfect? For multiple columns, which let's say are denoting the patient have cancer, such as this, how can we specifically draw this hypothesis testing? So now you are talking about multi-class classification problem. For multi-class classification problem, we as such directly cannot apply this kind of a testing. We will have two specific main pointers for which we can apply this hypothesis testing over it, right? So if you are saying cancer, now you're moving towards the types of cancer, so that will become a different problem altogether. That is where, if let's say we have a cancer, means we are somehow in this specific use case rejecting the null hypothesis. No, we will fail to reject it. Then it's a depthness in that part which you're talking about. But we usually taken care in this hypothesis testing the major problem which we have to encounter, not the sub problems for the same. Same thing you can say for sensor, Caesar, whatever be the multiple classes we have. But always remember, these task, these testing will be applicable for a broader level, not in the depthless level. You are working with the depthness of the cancer part. This specific use case, this specific hypothesis testing is applicable to diagnose the cancer patients. After which, what are the types of that? That is where, again, if you want to deep down into single specific problem, that is where you will apply the hypothesis testing. Always remember these two conditions. What is the specific condition you're doubtful about, and what is the specific condition you believe? That is where these two words will come into picture, not in a depth, wideness of the categories that we have. I hope it answers your question. For diabetes, type 1 and type 2 will be subclass classification. I didn't get your question, Mayur. Can you unmute yourself and ask?
Yes, am I audible?
Yes.
Whatever, uh, whatever the discussion was going on related to different forms of cancers, and that's why there what already explained that already mentioned that if we deep dive, then we cannot directly go for hypothesis testing. So same thing. Actually, I am talking about diabetes. So
Hmm?
if we more deep dive, then this things won't work, isn't it? If we it's only
Yes.
in case of diabetes, if we same thing if we apply, then we can directly say null hypothesis will be like which north or south,
Correct.
which is the diabetes, and while calculate taking the north, we will include the northeast also, or northeast will be in a different.
Sorry, what's the
I mean, the
last
north
question you
part.
said?
Whenever we're saying north, then it will include the
Uh-huh.
northeast also, isn't it?
Yes, correct, correct. From Mayur's question, I want to give you one task for today's class. Just you need to, explore about this. We have discussed today about type 1 and type 2 error, right? Let's try to apply that same thing in the diabetic patients data. Diabetic patients data. Now, there is a actual values we have. Actual value means that, uh, let's say that patient is diabetic. Actually, patient is diabetic. And let's assume that actually patient is not diabetic. There can be two possibilities. So either that patient will be diabetic or the patient will be not diabetic, right? And after that, you are doing some experiment and you got some conclusions. And the conclusions are that either, so this is null hypothesis that the patient is diabetic. The alternate one is the patient is not diabetic. So in your experimental result, let's assume that you are rejecting the null hypothesis, and either the conclusion is rejecting or you will be fail to reject the null hypothesis. ठीक है? So either you reject the null hypothesis or you fail to reject the null hypothesis. So what you have to do at your end, you need to fill these values and you need to tell me in the next class which one is the type 1 error in this use case and which one is the type 2 error and why. I will share this PDF with everyone, and you have to just take this PDF and uh, work around this matrix. This is a matrix of diabetic patient, and you need to fill all these four values, which two are the correct cases and which two are the type 1 and type 2 error. Don't answer it today. I want to give some time, take it, and then in the next class, we'll start our discussion from this topic. We'll ask the answer from you all. No need to send me personally via me email or any telegram messages. Take it with you. We have a session day after tomorrow. We'll meet again. We'll start from this topic. I'll discuss this topic first, ask you the question, answers for the same, and then from there we will start our next discussion. Will that be fine? Is the task is clear? What I want from you? Fine. Okay. Perfect. So I think we can wrap up the class now.